All right, hello everyone. Welcome back to GISC 1336. Today is going to be a little bit different as we switch from covering new topic discussions to a series of abridged lectures. These won't be about introducing a brand new Civil 3D command or unpacking a fresh case law precedent. This is about review, specifically for your midterm. It's about bringing together everything that we've covered in lectures 1 through 5 and preparing you for your midterm exam. I want this set of abridged lectures to serve as a complete resource. If you have no other study guide, no other notes, this review is intended to stand on its own as an abridged version of our course so far. You should be able to listen to this recording, review your practicums, and come away feeling ready for your exam. Remember, this course is not about memorizing long lists of repeating definitions word for word. Instead, it's about understanding the connections between ideas. How does the drafter's role link to TBPELS standards? How does surface modeling tie into evidence preservation? Why do case law decisions from the 1800s still guide plats that we draft today? That is what I want to emphasize in this review. And I'll remind you of what I told you from the very beginning. Every line you draw is either helping or hurting the certification of the surveying profession. That phrase is more than just a theme. It's the standard by which you should measure every decision you make as a drafter. So let's step back through lecture 1 through 5. Not as quick summaries, but as an abridged mini-series of lectures, each carrying enough weight that if you've only heard this review, you should still understand the essentials of the topics covered so far. To prepare for the exam, we're walking back through the major lessons of our first 5 lectures. In this section, we begin with Lecture 1, the Introduction to Survey Drafting. This lecture set the tone for everything that's followed, both in the profession and this course. It reminded us that surveying is one of the oldest human professions, that drafting is its permanent language, and that Texas carries unique demands because of its history. I want to begin with the overview that I gave you on the very first day. Every line you draw is either helping or hurting the profession of surveyors. That phrase is not just a warning. It is the heart of this entire course. It means that your work is not neutral. Each line, each symbol, each note you draft either adds clarity or creates confusion. Either it strengthens the surveyor's professional seal or it undermines it. And that principle has guided us from the beginning of time. So let's go back a little bit. Surveying is not a modern invention. It's as old as civilization itself. The ancient Egyptians were among the first surveyors that we knew of. Every year, the Nile River flooded and erased field boundaries. Egyptian surveyors used ropes, knotted at measured intervals, to stretch out straight lines and reestablish the limits of farms. In fact, the word geometry itself comes from the Greek roots meaning earth measurement. And the Egyptians gave us not just pyramids, but our first organized land surveyors. Mesopotamia, between the Tigris and the Euphrates rivers, also has some of the oldest survey records still intact. Clay tablets show property boundaries tied to temples, canals, and agricultural plots. Accuracy mattered because taxation and ownership depended on it. Even then, surveyors had to balance measurements with landmarks, much like we do today. The Greeks advanced surveying instruments with the dioptra, a device capable of measuring angles both horizontally and vertically. The Romans built an entire profession of surveyors, the agrimensores, They carried the groma, a cross with plumb lines to lay out right angles. With these tools, the Romans imposed grids on conquered lands, built their famously straight roads, and divided property for military settlements across their empire. Many of those grids are still visible today in Europe. And surveying continued through the Middle Ages with compasses and chains. And by the Renaissance, surveyors carried plane tables to sketch maps directly in the field. By the Age of Enlightenment, the theodolite had been invented, capable of measuring precise angles with telescopes and graduated circles. This is the foundation of modern surveying. When Europeans colonized the Americas, surveying became essential. In England's North American colonies, the Gunter's chain, 66 feet long, was standard. Colonial surveyors like George Washington used it to divide tracts and establish townships. After independence, the United States and Thomas Jefferson created the Public Land Survey System, known as PLSS. And under this system, land was divided into neat squares, townships, and sections. It was uniform, repeatable, and relied on simple grid geometry. But not in Texas. And that is one of the most important takeaways from Lecture 1. Texas is unique. Unlike most of the United States, Texas was not ever brought under the PLSS. Our land system hails from Spanish and Mexican land grants, later confirmed and extended by the Republic of Texas. These grants were not neat rectangles. They followed rivers, ridges, trails, and trees. They were measured not in acres, but in varas, each 133 and 1/3 inches long. This is why drafting in Texas is so demanding. Instead of the tidy grids, we inherit highly irregular tracks. Instead of section corners every mile, we deal with landmarks that may have shifted or disappeared with time. Instead of consistent acreage counts, we see descriptions that require a professional level of interpretation. And that brings us to drafting. Surveying has always needed a way to record results. The Egyptians drew on papyrus. The Romans etched maps on parchment. Spanish colonists drew diseños, sketch maps, of their surveys to make their work permanent, legible, and communicable across generations. Many of those sketches still preserved today in the General Land Office. This is why I've told you, the drawings you create are not simply visualizations. They are legal records, technical records, and historical records. Drafting, not in Texas, not in the US, not in anywhere in the world, is an afterthought to land measurement. It's how our survey speaks. It is part of the process. So let's connect this to the modern profession. Surveyors today use total stations, GPS, and drones. The precision of these instruments is extraordinary, but that does not erase the need for judgment. If a deed calls for a country that no longer stands, or a road that has shifted since the 19th century, the drafter must help the surveyor represent the evidence faithfully and factually. And here is where your errors matter. Closure errors are not just mistakes. They are failures of communication that can mislead anyone who relies on the drawing. When a plat does not close mathematically, it is not simply a technical glitch. It is a signal that something is wrong. Perhaps a transcription error, perhaps an omission, perhaps a misunderstanding of the deed. If the drafter does not recognize and communicate this, the error may enter the public record and cause disputes for decades. Lecture 1 also highlighted the ethical dimension of our work. Drafting is not just mechanical. It is professional. Every surveyor who seals a plat depends on the drafter's accuracy, consistency, and awareness. TBPLS, the Board of Professional Engineers and Land Surveyors, enforces this standard. The board holds surveyors accountable, but surveyors in turn rely on their drafters to meet the same level of care. This is why I've stressed since day one. The drafter is part of the chain of custody of evidence. Just as the field crew observes, records, and preserves, so does the drafter. A misplaced line, an omitted note, or an inconsistent symbol breaks that chain. It introduces doubt into the record. So, to summarize Lecture 1 in this review, surveying is ancient. Drafting is its permanent language. And in Texas, the irregularity of our land system makes drafting especially demanding. Accuracy is not optional. Historical context matters, and every line that you draw carries weight. I'll say it again because it's worth remembering before your midterm. Every line you draw is either helping or hurting the professional certification of a surveyor. This was true in ancient Egypt, it was true under the Roman agrimensors, and it's true today in Texas and across the Union. All right, our Abridged series now turns to Lecture 2, the responsibilities of the drafter. If Lecture 1 was about history and context, Lecture 2 was about defining your role. I began with a clear statement. The drafter is not simply a mechanical operator. The drafter is a professional with clear responsibilities. And that theme carried throughout our lecture. But what are these responsibilities? In Lecture 2, I described them in 5 categories: accuracy, consistency, communication, legal awareness, and quality control. Let's take each in turn, not as a bullet point list, but as a sequence of ideas, each flowing into the next. First comes accuracy. Accuracy is the bedrock. Without it, nothing else matters. Accuracy means that every bearing, every distance, every curve, and every note must be exact. If you transpose a number or reverse a bearing, you've destroyed trust in this survey. Accuracy is not just matching the field notes. It is also about faithfully representing evidence. For example, if the crew finds an iron rod and you label it as a pipe, you've introduced an inaccuracy. If you type 345.63 feet where the deed says 354.63 feet, you've changed the property itself. Accuracy is what separates professional drafting from careless line work. Second comes consistency. Accuracy deals with the correctness of individual elements. Consistency deals with the uniformity of the whole. Consistency means that the line types, layers, blocks, and textiles are the same across your drawings. It means your plat looks like it belongs to the same professional office, whether it was drawn yesterday or 10 years ago. Civil 3D templates, style libraries, and sheet sets are tools that enforce this consistency. If one drafter uses a dashed line for a fence and another uses a solid line, confusion may result. Consistency eliminates that confusion, prevents it before it starts. It also protects the firm's reputation. A surveyor who reviews your plat should immediately recognize the standard it meets. Third comes communication. Your drawings must be readable and clear to people who were not in the field and did not collect the data. Think about who looks at a plat. Engineers, attorneys, judges, clerks, landowners. Many of them will not understand survey jargon. If the drawing is cluttered, if notes are vague, or symbols are not explained, then the plat has failed in its purpose. Communication means thinking about your audience. It means using legends, clear notes, and logical organization so that the truth of the survey can be understood by anyone who needs it. Fourth comes legal awareness. I told you then, and I will repeat it now. You may not be the one sealing the plat, but you need to understand the rules outlined in the Texas Administrative Code and how the board enforces them. Legal awareness means knowing that a plat is not just a technical drawing, it is a legal document. Board rules in the Texas Administrative Code, Title 22, Chapter 663, spell out what must appear on plats, how surveys must be certified, and what standards apply. Even though you are not signing the plat, you are producing the document that will carry that signature. If you omit required information, you have put the surveyor at risk of disciplinary action. Legal awareness also means knowing case law, such as Stafford v. King, which teaches us how evidence is weighed. And finally, we have quality control. The drafter is the last line of defense before a survey is recorded forever. Quality control means catching mistakes before they become permanent record. It means checking closure, checking line work, checking spelling, and checking scales. It means comparing the plat to the deed and the field notes. If something does not match, you must flag it. Quality control is not fun, but it is essential because a survey that fails quality control is a liability to that homeowner, to that surveyor, to you in your own career. And these 5 responsibilities, they're not just theoretical. In Lecture 2, we explored scenarios that show how they play out. Imagine that a fence has stood on a line for a century, and you choose not to show it because it looked messy. That omission could erase evidence of a long-standing occupation. Imagine you clean up a plat by straightening a riverbank that meanders irregularly. You might think you're improving the drawing based on a legibility standpoint, but in fact, you're falsifying evidence. Imagine you use different line types than your colleagues. A judge may misinterpret the meaning of your symbols, and each of these violations hits is a hit against your required expectations. Now, Civil 3D, it gives us tools to uphold these standards. Templates ensure that every new drawing begins with the same layers, text styles, and plot settings. Styles define how points, surfaces, and alignments appear, ensuring consistency across our projects. Sheet sets organize multiple drawings into a single project, maintaining uniformity. Blocks standardize symbols, so a found monument looks the same in every plat. These are not tools, they are part of professional drafting. Lecture 2 also emphasizes that your role is proactive. You are not waiting for instructions. You are actively ensuring that accuracy, consistency, community, legal awareness, and quality control are upheld. You are part of the chain of custody of evidence. Just as field crews observe and record, you preserve and communicate. And I remind you of the stakes. If a mistake enters the record, it may live there indefinitely. A misdrawn line can create disputes, mislead courts, or misallocate property. Surveying is about certainty, and drafting is the visible face of that certainty. So, to summarize Lecture 2 for your review, accuracy ensures that each element is correct. Consistency ensures that the whole drawing is uniform. Communication ensures that anyone can understand it. Legal awareness ensures compliance with the board. And quality control ensures that nothing slips through. The drafter is not simply a mechanical operator. The drafter is a professional with clear responsibilities. That is what your midterm will expect you to know. Not just the definitions of accuracy or consistency, but how they play out in practice. How a fence line, a Plat symbol, or a civil 3D template can make the difference between a survey that is clear, lawful, and permanent, and one that is confusing, misleading, and flawed. Now we turn to our abridged version of Lecture 3, Surfaces and Grading. If Lecture 1 gave us the history and Lecture 2 gave us the responsibilities of the drafter, then Lecture 3 brought us into the technical heart of digital drafting. Here, we moved from the idea of responsibility to the tools that allow us to preserve the truth of the ground. I began Lecture 3 by reminding you that surveying is not only about boundaries, it is also about representing the shape of the land. Elevation, slope, drainage, and grade are all part of what the survey must communicate. In Civil 3D, that begins with surfaces. A surface is a model of the ground, built from point data. Points come from total stations, GPS, drones, or LiDAR equipment. In Civil 3D, these points can be used to create either a grid surface or a tin surface. A grid surface is a simple matrix of elevations, but it struggles with irregular terrain. A tin surface, a triangulated irregular network, connects points with triangles, allowing contours to flow naturally across the ground. Most of the time in surveying and construction, we'll use tin surfaces because they balance accuracy and efficiency. As to our grid surface, or DEMs, are going to allow us to observe much larger regions, such as counties, states, and some nations. But building a surface, again, it's not just pressing a button. Raw data does not tell the whole story. Break lines must be added to preserve the shape of critical features. Ridges, streams, ditches, retaining walls. If break lines are missing, our surfaces will smooth over these features and misrepresent our land. Boundaries must also be applied, limiting the surface to the area of interest and preventing stray triangles from distorting our contours. And once our surface is created, it can be displayed with contours. Contours are not just lines on a map. They are the language by which we communicate the shape of the ground. A contour is a line connecting points of equal elevation, but choosing contour intervals requires judgment. Too close, and the drawing becomes a dense web of lines. Too far apart, and important details become lost. A subdivision plan may use 1-foot contours, while a county-wide map might go for 20-foot contours. As the drafter, it's you who must choose intervals that balance clarity and accuracy. We also explored grading tools. Grading is about modeling how the ground will change. Feature lines define slopes. Grading groups allow us to calculate cut and fill. Slope analysis highlights areas too steep for safe construction. Civil 3D even allows you to model drainage paths, catchment areas, and stormwater flows. These are not just engineering exercises. They matter to surveyors and drafters because they affect how land can be used. For example, if your grading misrepresents slopes, a site might appear suitable for building when it is not. If your contours suggest drainage flows away from a building when in fact it flows towards it, you've created a danger misrepresentation of the land. Surveying and drafting are not only about describing the land as it is. Sometimes they're about modeling the land as it will be. Either way, accuracy and fidelity matter. And this is where field data is critical. If a field crew fails to shoot enough points on a ridge, that surface will flatten. If they miss the bottom of a ditch, that ditch will disappear. And if you, as the drafter, fail to process the data carefully, break lines may not be applied, and the surface will be wrong. Surfaces are only as good as the data and the drafter who processes them. That led us into the concept of field to finish. This process links the field crew and the drafter into one continuous chain. Crews collect points with standardized codes. Each code corresponds to a layer, symbol, or block in Civil 3D. When imported, the points automatically create line work, place symbols, and build surfaces based on the key sets that you've established. Some organizations in Texas, like TxDOT, will have standardized codes. IRF for iron rods found, IRS for iron rods set, PK for nails set in asphalt, MON_TR for tree monuments, FNC for fences, EP for edge of pavement, CL for centerline. These codes mean that when the point file is imported, fences can draw themselves, pavements are delineated, and monuments appear with correct symbology. I told you in that lecture, field to finish is a chain of custody for evidence. The moment something is observed in the field, it is preserved, imported, and recorded. That phrase captures why field to finish matters. It is not just about efficiency, though it does save time. It is about preserving the truth. If a crew codes a fence and you delete it from the drawing because it looks messy, you've broken that chain of custody. If a river meanders, but you straighten it for aesthetics, you have falsified evidence. We also looked at the consequences of getting surfaces and grading wrong. Suppose you're drafting a site for a proposed subdivision. Your contours are generalized poorly, and you miss a depression that floods after a heavy rain. If that subdivision is built, homes may flood. Imagine you miscalculate cut and fill volumes. The contractor may move thousands of cubic yards on earth unnecessarily, costing money and time. These are not abstract problems. They are real consequences of inaccurate drafting. And while Civil 3D does provide powerful tools, they must be used with care. Description keys, point groups, label styles all have the capability to automate your work, but they depend on a correct setup. They depend on proper field collection. If your description key file mislabels a code, every point imported with that code will come out wrong. If your point group excludes necessary points, your surface will be incomplete. As the drafter, you are responsible for verifying that the automation is correct. In Lecture 3, I emphasized that surfaces and grading are not just computer exercises. These are legal and ethical responsibilities. Just as plats must represent boundaries truthfully, Surfaces must represent the land truthfully. A misdrawn contour is a misleading and misdrawn boundary. So let me summarize this abridged lecture. A surface is a model of the ground, most often a tin built from point data. Break lines and boundaries ensure fidelity. Contours communicate elevation, but intervals must be chosen wisely. Grading tools model change, calculate slopes, drainage, and volumes. Field to finish preserves evidence from observation to plat using standardized codes. And above all, fidelity to evidence is your responsibility. Field to finish is a chain of custody for evidence. The moment something is observed in the field, it is preserved, imported, and recorded. That is the essence of Lecture 3, and it's very important you remember that going into your midterm, into your professional careers. All right, let's start our abridged Lecture 4, Plats and Plat Preparation. This was the lecture where we confronted the reality that the drawings we produce are not just technical records. These are legal instruments that carry the weight of law. I began Lecture 4 with a statement to frame everything. A plat is not simply a picture, it is a legal instrument that speaks for the surveyor. That phrase captures why this lecture was so important. Once a plat is filed, it becomes part of the public record, and it may be relied upon by landowners, agencies, engineers, attorneys, judges, and even future surveyors who have not yet been born. Maybe some of you in this room. The drafter plays a direct role in shaping how the truth of the land will be carried forward for generations. So, what does the board require of plats in Texas? Let's walk through the elements. First, every plat must have a title block that includes the surveyor's name, registration number, and firm registration number. The title block must also identify the tract being surveyed, often with references to volume and page in the deed records or instrument number. This information roots the plat in the legal system of property records, or our cadastre. Second, the plat must have a basis of bearings. This is not optional. The basis of bearings tells the reader how directions on the plat are defined. It might be grid north, it might be true north, or it might be a bearing between two monuments. Without a basis of bearings, directions become meaningless. Third, the plat must contain a closure statement. This demonstrates that the survey meets board accuracy standards, typically 1 to 10,000 for urban surveyors and 1 to 5,000 for rural surveys. Closure is not about mathematics. It is about confidence. It tells the reader that the survey closes properly and that the drafter has checked the math. Fourth, the plat must note every monument found or set. If the crew finds an iron rod, you must show it. If they set a new iron rod, you must show it. If they recover a stone mound, it must appear. Monuments are the backbone of our surveys. They are the physical evidence that ties the paper to the ground. Fifth, the plat must show adjoining tracts. Each adjoiner must be identified by owner name and deed reference. This is not only courtesy, it prevents gaps and overlaps. Boundaries exist in relation to neighbors, and the plat must make that relationship clear. Sixth, the plat must show all easements. Easements are rights held by others across the land. Utility lines, pipelines, access road. All of these must be shown and labeled. If you omit an easement, you conceal rights that belong to others. Seventh, the plat must have a legend explaining all symbols used. Symbols that are not explained are meaningless. A reader should not have to guess whether a small circle is an iron rod or a water well. And finally, the plat must include the surveyor's certification. That certification is a signed and sealed statement that the survey was performed according to board rules, at the surveyor's legal and ethical guarantee of accuracy. Hopefully, one day, every single one of you will have a seal of your own. That's the goal. Now, I want to stress that these requirements are not just a checklist. Each one preserves the truth. The title block ties the plat to the deed records. The basis of bearings explains direction. The closure statement guarantees accuracy. Monument notes preserve physical evidence. Adjoiners prevent overlaps. Easements protect third-party rights. And the legend ensures clarity. Last, the certification makes that survey legally binding. In Lecture 4, we also placed plats in their historical context. Long before Texas was part of the United States, Spanish colonists prepared diseños, or hand-drawn sketches of land grants. These sketches often relied on rivers, trees, and trails as their boundaries. They were crude by modern standards, but they still define property rights today. During the Republic of Texas as a sovereignty, surveyors prepared plats and field notes that are preserved in the General Land Office. These documents continue to guide boundary decisions. And the lesson here is that plats last. They often outlive the people who draw them, and they continue to carry legal weight centuries later. That brings us to ethics. I told you in this lecture that a poorly drafted plat is not just sloppy. It can mislead courts, harm property rights, and put a surveyor out of compliance with the board. It also erodes public trust in our profession. This is not an exaggeration. Imagine a plat that omits an easement. A landowner may build over a utility line, leading to litigation. Imagine a plat that mislabels an adjoiner. Two neighbors may end up fighting in court over land that was never in dispute until your mistake was made. Imagine a plat with poor closure. A county clerk may reject it, delaying projects and damaging firm reputations. In some cases, plats are read aloud in courtrooms. Judges and juries may rely on them to determine property rights. When that happens, the clarity of your drafting becomes the clarity of justice itself. If a juror cannot understand your plat, then the surveyor's work has failed in its job to communicate. Sorry. And Civil 3D plays a role here as well. Templates are going to help enforce standard title blocks. Styles will ensure that monuments, easements, and adjoiners are represented consistently. Label styles generate deed references automatically. Sheet sets keep multiple pages organized. These tools do not replace your judgment, but they do enforce uniformity. The deeper lesson of Lecture 4 was that plats are not just drawings. These are legal instruments. Every line on a plat may have consequences for decades or centuries. And this is why the board has strict rules. And that is why your role as a drafter is critical to the surveying profession. So, to summarize Lecture 4 for this review, or for this abridged version of the lecture, plats must include a title block. basis of bearings, closure statements, monument notes, adjoining tracts, easements, a legend, and the surveyor's certification. Each element preserves the truth. Historical plats remind us that records endure. And ethically, your duty is to represent reality faithfully and factually. A plat is not simply a picture, it is a legal instrument that speaks for the surveyor. This is what you'll be carrying into your midterm exam, not just the list of required elements, but the understanding that plats are legal artifacts, and your drafting decisions are legal decisions in disguise. Welcome back to our abridged series of lectures from GISC 1336. We now arrive at Lecture 5, Boundary Surveying in Texas. If Lectures 1 through 4 gave us the tools, the responsibilities, and the technical processes, Lecture 5 gave us the framework of law and history that holds everything together. I originally began this lecture by reminding you that Texas is not like most other states. Unlike much of the United States, Texas was never brought under the public land survey system. Instead, our land system descends primarily from Spanish and Mexican land grants, confirmed later by the Sovereign Republic of Texas. These grants did not fit neatly into square townships and sections. They followed rivers, ridges, trails, and trees, alive with the land around them. They were not measured in chains or acres. They were measured in varas, each one 33 and 1/3 inches long. This is why I told you then that Texas boundaries are irregular, and they require careful interpretation of evidence. To work in Texas is to work with deeds that describe a tree that may no longer exist, a stream that has changed course several times over, or roads that have shifted as populations have grown. It requires not only technical drafting skill, but also judgment rooted in law and precedent. So in Lecture 5, we focused on 4 landmark cases that still govern how we weigh evidence in Texas today. The first case we studied was Stafford v. King, decided in 1867. This case involved a dispute where the written deed called for certain courses and distances, but the monuments on the ground did not match. This left the court questioning what should prevail, the numbers in the deed or the physical monuments found on the land. The court ruled clearly. Monuments prevail. The reasoning was simple but profound. Numbers can be wrong. Chains can stretch. Compasses can err. Transcriptions can mistake distances. But monuments, trees, rivers, iron rods, stone mounds, are physical evidence. They were set or called for by the original surveyor, and they tie the record to the land itself. It is a reflection of intent. From this case, the court gave us the hierarchy of dignity of calls, which still governs today. Natural monuments come first, because rivers, ridges, and trees are the strongest evidence of original intent. Artificial monuments come next, because an iron rod or a stone mound placed by a surveyor is also strong evidence. Adjoining tracts follow, since long recognized occupation by neighbors may establish boundaries. Course and distance were next, the bearing and measurements written in our deeds. And last of all was area, the acreage described, holding the least amount of weight against all other forms of evidence. And out of Stafford v. King came a phrase that still echoes through surveying. The footsteps of the surveyor upon the ground should always be followed. That is the heart of boundary law in Texas. We do not blindly follow the math. We follow the evidence. We walk in the footsteps of the surveyor who first laid out the land before us. The second case we studied was State v. Post, decided in 1914. This case involved a resurvey of land originally granted by the state. The resurveyor attempted to enlarge the acreage, arguing that his new measurements were more precise than the original. The question was whether a resurveyor could expand or correct the boundaries to improve an original work. Again, the court ruled firmly, no. Resurveys retrace, they do not redesign. The job of the resurveyor is not to redraw the land according to new math. It is to follow the footsteps of the original surveyor, to locate the boundaries as they were originally marked. Even if the original measurements were imperfect, the physical monumentation is what defines the land. This case matters for drafters because it reminds us that newer is not always better. Civil 3D may allow us to calculate bearings and distances with great precision, but it does not override the evidence of the original survey. When you draft, you must represent what was done, not what you wish had been done. If the original tract was granted at 642 acres, you can't redraw it as 650 acres just because it's the way your math closed. State v. Post teaches us humility. Our role is not to perfect the past, but to represent it truthfully. The third case we studied was Strayhorn v. Jones, decided in 1957. This case involved riparian boundaries, land along a river. The deed called for boundaries that followed the meander of a river, but the survey showed meander lines drawn some distance from where the stream was. The dispute was whether the meander lines or the river itself defined the boundary. The court ruled that the river is the boundary. Excuse me. The court ruled that the river is the boundary. Meander lines are guides. They approximate the course of the stream, but they do not replace it. The river, in all its irregularity, is the true line. This decision is critical in Texas, where so many grants have been defined by rivers and streams. Watercourses move. They erode banks, shift channels, and create new meanders. The law distinguishes between accretion, where land builds gradually, and avulsion, where land shifts suddenly. But in either case, the river itself is the controlling boundary. For drafters, this means you cannot straighten a river on a plat just to make it look cleaner. You must represent it as it is, meanders and all. If you delete a bend, you have misrepresented the boundary. That is why we say again, when you draft, you are not just making a picture. You are preserving the truth of the land for future generations. The fourth case we studied was Hicks v. Lovelace, decided in 1986. This case involved overlapping deeds. Two grants covered the same land, and the question posed to the court was which deed should prevail, the older or the newer. The court ruled that the senior deed prevails. First in time is first in right. If two grants overlap, the older one takes priority. The junior deed is limited to whatever land remains outside of the senior grant. For drafters, this case reinforces the need to research adjoiners carefully. If you omit adjoining deed references, you may conceal conflicts. If you mislabel tracts, you may mislead. Hicks v. Lovelace teaches us that Hicks v. Lovelace teaches us that chronology matters. The order of grants defines the rights. These four cases reinforce the hierarchy of evidence. Natural monuments come first. Artificial monuments come second. Adjoiners and occupation come third. Course and distance come fourth. And distance and area comes last. This hierarchy is not arbitrary. As you'll later read in the textbook Elementary Surveying, the monuments and occupation preserve original intent better than numbers. Bearings and distances can be wrong. Acreage is often approximate. But a river, a stone mound, or a long-standing fence carries weight because it reflects the original surveyor's footsteps. For drafters, this hierarchy means you must represent all evidence. You cannot omit a monument just because it conflicts with your math. You cannot delete a fence just because it looks messy. And you cannot ignore a river's bend just because it complicates closure. Your job is to preserve all evidence, leaving it to the surveyor and sometimes the court to decide how this evidence should be weighed. We also tied this back to field to finish, especially in the TxDOT survey manual. Crews in the field collect evidence with standardized codes. IRF for iron rods found, IRS for iron rods set, PK for nails, MON_TR for tree monuments, FNC for fences, EP for edge of pavement. When imported, Civil 3D builds line work, places symbols, and assigns layers automatically based on these codes. But as I stressed, the point is not efficiency. The point is fidelity. Field to finish is about preserving evidence exactly as it was observed. If a fence is coded, you must show it. If a river meanders, you must draft it. And if old stone monuments are called for, they must be labeled. The drafter is the guardian of that chain of evidence. And that chain of custody is what connects field observations to public record. If you break it, you have now compromised the integrity of the survey. So, to summarize Lecture 5 for your midterm review, know this: Texas is not a PLSS state. Our boundaries are irregular, shaped by Spanish and Mexican grants and Republic patents. They require interpretation of evidence. The cases of Stafford v. King, State v. Post, Strayhorn v. Jones, and Hicks v. Lovelace give us the rules for weighing evidence. The hierarchy of evidence, natural monuments, artificial monuments, adjoiners, course and distance, and area, governs how conflicts are resolved. And field to finish, especially as practiced by TxDOT, will preserve evidence from observation to plat. Remember again the words of the court in Stafford v. King. The footsteps of the surveyor upon the ground should always be followed. This is the standard. And remember too, when you draft, you are not just making a picture. You are preserving the truth of the land for future generations. This is the overview of Lecture 5, the essence of what we're trying to teach. Carry this with you into your midterm exam, and especially keep that hierarchy of evidence close to heart as you engage in your professional careers. So, as we close out our midterm review, I want to take a step back and remind you of the larger story that we've been telling across these first 5 lectures. Each lecture was not intended to be a separate island of information. Each one has been a piece of a whole. Together, they form a chain of understanding about what it means to draft and design in the service of surveying, and what it means to do so in the state of Texas. We began in Lecture 1 with history. We saw that surveying is one of our oldest professions, practiced by Egyptians measuring along the Nile River, by Romans laying out roads and colonies with the groma, and by Spanish colonists sketching Diseños in Texas. We learned that every line you draw is either helping or hurting the surveyor's certification, and that drafting is not just a convenience, but the very language by which surveying speaks across centuries. In Lecture 2, we turned to the responsibilities of the drafter: accuracy, consistency, communication, legal awareness, and quality control. These are not just checklists, but habits of mind. They are the traits that make your work reliable. We saw that the drafter is not simply a mechanical operator. The drafter is a professional with clear responsibilities. And those responsibilities mean that your decisions affect surveyors, landowners, courts, and history itself. At Lecture 3, we dug into surfaces and grading. We saw how surfaces built from point data represent the land as it is. We saw how grading tools can model the land as it may be. We learned that contours are not just lines on a map. They are the language by which we communicate the shape of the ground. We learned that field to finish is not about efficiency, but about preserving the chain of custody of evidence. Every shot in the field, every code entered, every point imported must be preserved truthfully. In Lecture 4, we turned to plats. We learned that a plat is not simply a picture. It is a legal instrument that speaks for the surveyor. Title blocks, bases of bearing, closure statements, monuments, adjoiners, easements, legends, certification, all of these, not just formalities. These are pieces of a legal record that may be read in the courtroom, relied upon in a deed, or used to resolve disputes long after we're gone. And finally, in Lecture 5, we stood on the shoulders of great Texas surveyors in case law. Stafford v. King reminded us that monuments prevail and that the footsteps of the surveyor upon the ground should always be followed. State v. Post taught us that resurveys retrace, they do not redesign. Strayhorn v. Jones reminded us that rivers themselves, not meander lines, are the boundaries. Hicks v. Lovelace told us that senior deeds prevail. All of these cases reinforced the hierarchy of evidence: natural monuments first, artificial monuments second, adjoiners third, courses and distance fourth, area last. They showed us that drafting is not mathematics alone. It is law, history, and evidence intertwined in a digital environment to represent the land. So, as you're preparing for your midterm, remember that this course, again, it's not about memorizing software commands or legal citations in isolation. It's about understanding how surveying, drafting, history, and law come together. It's about understanding that you, as a drafter, are part of a professional chain of custody. You are not simply drawing lines. You are preserving evidence. You are not simply producing graphics. You are shaping legal records. And you are not simply helping a surveyor. You are helping generations of people understand the truth of land. Carry with you the phrases that I've repeated throughout this review. Every line you draw is either helping or hurting the surveyor's certification. The drafter is not simply a mechanical operator. The drafter is a professional with clear responsibilities. Contours are not just lines on a map. They are the language by which we communicate the shape of the ground. A plat is not simply a picture. It is a legal instrument that speaks for the surveyor. The footsteps of the surveyor upon the ground should always be followed. This review should serve as the guideposts for your exam, but more importantly, they should serve as guideposts for your careers. Thank you, and good luck on your exams.